right? And for today, give me 1 minute, guys. Right, so I'm going to so I've picked up a code from the Microsoft documentation. I'm going to do some cleanup. All right, so let's look at this code. So it is defining two variables, x and y, account, and a multi-dimensional array. Now it is populating this array with the string value of the count. So I and j, there are two loop statements that are running. What I want to showcase is that there is a goto statement, and then this goto statement is looking for an element, and as soon as that element is found, it is going to jump to found, and if it doesn't find anything, this for loop is going to end. It is going to come here and it's going to say that number is not found, and to avoid this found statement, it is using another label called goto finish. Right? And then this goto finish is jumping to end of search. So let's go ahead and run the statement, run this program. All right, so there is some I'm sorry. So this is coming from some other. So if I run this code, no entry point defined. So let's go ahead and modify this to copy structured demo and replace it here in the program.cs file. All right. So now if I run this, it is going to ask for a number. And if you look at our code once again, it is running this loop for 200 times and the inner loop for 4 times. So maximum value is going to be 800. So let's just search 500, and 500 is found at its end of search. And if I enter anything bigger than 500, say 900 was not found, and it is going to end of search again. But then those two statements themselves, they are sitting under a label. So if it is found, it jumps to this particular label, which is defined with a colon sign, and the finish is also defined with a colon sign. Now you see that it's an overlap of a code. When everything goes fine, it runs through this line, and after this, it goes to go to finish. And when it comes here, it jumps everything. It jumps these two statements, and it comes down over to this particular line here. Now, this kind of code, C# and advanced programming languages, they have a restriction that this label cannot be present in another file. So I cannot declare another function public void test and declare a label here. At least I'm guessing so. Go to new found. So new found is not defined at the moment, but if I define new found here like this, it is still going to complain that this label is not found within the scope. But then with older languages, this label could have been present in another function as well. And then this was a recipe of disaster. Your code will be extremely unreadable, and you would not want to do that. A better way of writing this kind of application is without a goto statement is that instead of jumping over here like this, at the end of this loop, you probably set some sort of flag, which is against functional programming. But then the way I would do it is I'm going to declare a variable called found assigned to false. Over here, I'm going to say found assigned to true. And then if found equal to true, I'm going to print, I'm going to call this function, else I'm going to call this function over here. And it is the end of search. I'm going to leave that message as is and probably delete this comment as well. So the bunch of goto statements that we had before, we replaced them with the if else clause, right? If else has better control flow. All right. So now if I give 200, it is going to find 200 using those multiple loops. The output essentially is exactly the same. We have not influenced the output, right? We have not changed anything in the output, but in the way we are writing this code is a little neat. And if I have to, okay, let me see. We can do this, right? What this code essentially is doing is it is setting these flags. And if I have to draw a flow diagram for this, it's going to look a little complicated. This is the outer for loop. This here is the inner for loop. And then this if statement here is the little block. So that block can be represented, say, with this particular triangle, and it then goes to this section, draws another triangle, and over here it prints found. Over here it prints not found. In this particular statement, if everything goes through fine, it sets the flag to true, right? This code is a lot readable compared to the previous code, which was jumping around in 3 different sections. And if interfunctional jumping is allowed, this is going to get a lot more complicated. Make sense? Using the same technique, you can implement a while loop as well, like go to a statement and then you increment the count and then you check again. But then that is what functional programming is, that you do not use go to statement. So let's go ahead and build our next demo. I'm going to hit Control, Alt, Shift, and C, and I'm going to say OOP demo. And let's go ahead and wire this up. All right. Now, if I write 3 functions, I'm simply going to say F1, F2, and F3. And let's go ahead and define those functions right here in line, like void. Makes sense? I'm going to change this to F2, F2, F3, and F3. Let's go ahead and run this program. No surprises there. We're calling the main function is calling run. Run is calling all these three functions, and they are printing the expected output in the order. Now, suppose that this was the complex code that was connecting to the database and extracting out a lot of value. And tomorrow you want to you want to change the way this function is getting called, right? You will have to come and modify this function. Right? You will have to probably switch to F4, or you will have to modify this particular function. And every time you run into that kind of condition, you will have to do a lot of regression testing. A regression testing is a term that you will have to verify that the code that you have written, the code that you have written has not affected any other component of the application, and your application is still intact. Calling functions like this, it kind of gets in the way, right? If we are to fix it, we are going to define multiple classes. So let's call it an interface. I'm going to call it IF1. And the IF1 is going to have a member. I'm going to call it do something. And then this F1 is going to have an implementation. It's going to say F1 implementation. There's going to be a class. And I'm going to extend the IF1 function over here. If I control dot now and say implement interface, it is going to give me the default body. And over here, I can say F1 once again. And I can repeat this thing for all three implementations. So this one I'm going to change to F2. And it is F2 implementation that does something. And this is going to be F3, F3 implementation, F3 implementation. And this is going to be all right, looks good. Now I'm going to come back to the OOP demo part, and I'm going to comment this code out. I'm going to say my application says that I do not depend on the concretion. I depend on the abstraction. Now, for using those abstraction, I should have member variables like this, to which I'm going to assign new values. So for this, I'm going to use F1 implementation. I'm going to repeat this line 3 times. This becomes F3. And F3. Now, if I have to do the actual run, I'm going to say F1 dot do something. And once again, I'm going to change this to F2 and F3. Now, if I run this, once again, our output has not changed. It is the same output that we were receiving earlier as well, but this time we don't know which functions to call or what these functions they are internally going to do. Right? We only know that somebody has implemented this particular thing, this particular abstraction, and they are taking care of doing everything required for performing that operation. That operation for us was, say, connecting to database. Now, instead of knowing the function that is going to connect to database, we know the abstraction that is promising us that it is going to get us data. We don't care. We are not affected by knowing the internal implementation details. Makes sense? But then once again, somebody could come and say that, hey, if I want to provide this implementation, this function is going to get modified, right? I will have to come and put probably say F4 implementation over here, like the change in function name. So we are going to take away the ability of object creation from this function, and we are going to put it somewhere else. So I'm going to do it in 3 steps. The first step is I'm going to move everything outside, and to modify multiple lines, you can do Shift and Alt, hold them together and click everything that you want to modify. And I'm going to put 1 underscore sign like this. After this, I'm going to define a constructor, and this constructor is going to take these three parameters. If1 is going to take if2, and this one is going to take if3, like this. Now, I do not put underscore in the member parameters. This is one of the coding standards, and I put underscore for private members. So I'm going to say f1 assigned to f1. I'm simply going to modify this to 2, this to 3. And once again, I'm holding Shift and Alt, and I'm going to copy this. And I'm going to delete this part here. All right, so the OOP demo itself, I don't know what it is complaining about. Inconsistent accessibility. So this will come when your interfaces are not public and your constructors are public. So I'm just going to come here and put the public keyword and leave these classes private. Then I'm going to come back to the main function, and over here it has already started complaining. It is saying that there are 3 arguments that we'll have to pass. So we're going to declare that over here like this, put a semicolon, and once again, I'm going to delete these 3 underscores. And I'm going to pass f1, f2, f3 to this particular constructor. And then now, no matter what, now it is still complaining. Inconsistent type if2. Yeah, I'll have to put the public keyword here as well. And the public keyword here as well. With this, we are initializing 3 implementations with this new keyword, and the OOP demo is taking those 3 parameters and it's going to run the application. If you go inside the OOP demo, this error has been fixed, and then I'm going to have to put the underscore keyword because those variables were not found. Now, the run function, regardless of where you want to read the data from, if you want to read it from database, if you want to read it from some other implementation, this run function will always stay the same. And as long as this function is same, the testing efforts that you will have to put in because of a modification is going to be very, very minimal. Let's go ahead and see if our output has changed. Right, output is still the same. Let's go ahead and influence that. We are going to once again come to our interface class, and I'm going to say that class f4 implementation or new f1 implementation, and I'm going to extend the if1 interface, and I'm going to use Visual Studio to develop some code for me. I'm going to say implement interface. It's going to give me this code. And now I'm going to change the output a bit. Connecting to a database. F1 from database. And then all I have to do is I have to change the wiring. Now I'm going to switch from F1 implementation to new F1 implementation. And now if I hit Control F5, instead of reading data from the F1 implementation class, it is reading from new F1 implementation. And the output has kind of changed, and we did not touch the run function at all. Right? This function has stayed the same. Right? And this is true object-oriented programming, that you have taken away the ability of the function to know the implementation details. We have actually reversed this particular flow here. Now the function knew which function to call. Now the function doesn't know which function is getting called. Right? As long as you are replacing this green block, this main function is going to stay the same. All right, and this is where object-oriented programming or OOP is going to really start paying. And this is all possible because there is dynamic polymorphism. We are creating an object outside the knowledge of that particular function. We are injecting the object from the outside, and through this, the code that we are writing can be modified. The flow of the application can be modified from the outside. So the policy is that we have to call 3 implementation to get the job done, but then the policy does not give you the detail. the detail is controlled from the outside. Make sense? So this is object-oriented programming for you. And we're going to finish our last demo for this part of the section. And I'm going to call it functional demo. And the public void run function here like this. Now, in the run function, I'm going to call a function called calculate age. Then let's go ahead and define that function. It's going to take datetime dot now dot add years, and I'm going to pass minus 30. So it's going to go back 30 years and calculate age is going to take that parameter. And I'm going to call it date of birth. Let's change this to time lapse. Time lapse is another time span. Actually, it's not time lapse. Time span is another CLR data type, which holds difference between two datetime instances. So what I'm going to do is I'm going to return datetime.now minus the date of birth. And inside this function, I'm going to accept the response as age. And let's print age in dot. So it's total seconds. It's total seconds, total milliseconds. Let's go ahead and do total seconds because we're going to run this application multiple times. I'm going to hit Control F5. And then this time the output is let's focus on these last three digits. 1988. All right. So these are two different outputs, right? Notice that it was 1988 and then now it is 2006. Those are number of seconds, milliseconds, how frequently we are running. But then this function is discouraged in functional programming. Functional programming says that for the same input, you should always get the same output. And one way to fix this is that you give it the reference time. Datetime dot. So I'm going to create a new datetime object. New datetime in line here like this. And I'm going to give it. So let's look at the definition of this constructor, and it takes year, month, and day. So I'm going to pass it 2021, and then it is June 21, I guess. Calculate age, instead of one parameter, it's going to take two parameters now, and it is going to say what is the reference date with which you want to calculate the date of birth. And now it is not going to be datetime.now, it is going to be the reference date. And now if I hit Control F5, no matter how many times I run this application, let's go ahead and I'm getting different outputs. I'm going to set these three values as well. I don't know why it is doing that, but then I hope you got the idea. So I'm getting different output. Let me show it to you. So this was the first output, and this was the second output.
Sir, that may be due to you have used age.total seconds in the console.write line.
No, I was hoping for something like this. I was hoping for something like this, that if I pass 20 here and 10 here, right? If I take a difference, that difference should always be same. So it is not this, it is the way I'm creating the datetime object. It is taking a time.
It is datetime dot now minus 30 years. So datetime dot now is changing every time.
There you go. So yep, good catch, Sahil. Thanks, man. So for somebody who is born in say 1991, it is always going to be the same. So it is new datetime. Right now it is going to be the same. Thanks, man. Good catch. Right. No matter how many times you run it, we are going to get the same output because we are like subtracting two constant numbers. Right. So when you are working on, say, even a banking transaction application, the example that we were seeing here was this, that you do not store the account balance. Instead, you save the account transaction, and when somebody wants to know the account balance, they'll have to give a timestamp as well, right? And at that particular timestamp, we'll always have, say, this is 20th of June, like till yesterday, 2021. The balance was this. If they want to get a constant result for the account balance, they'll have to pass a timestamp. And with this timestamp, we are only going to calculate till that particular point, right? It might appear that functional programming is extremely memory inefficient, and that is true. But the benefit of that is you will never run into an inconsistent system. Your system is always going to have a constant predictable state, and that is extremely required when you are writing difficult enterprise applications. Okay, so that is functional programming for you. So with that, let's take a quick break. We're going to come